So we are going to study in our today's class calculation of the valency. Remember, this is the most important in class 10th also. Class 10th, every chapter will be having importance of valency of metals and non-metals. Because there, one chapter, chapter number 3 in class 10th is metals and non-metals. And there is no equation and there is no chemical formula without knowing the valencies. So that's why it's very, very important. So learn very, very carefully this one. Formation of ions also. So now if you notice it, calculation of the valency, this valency is different for metals and same way valency is different for non-metals. So now before going to study this one, so let us discuss. We all studied two things. Of course, even valence also I taught three things. First of all, I need to know response from you all. What do you mean by valence cell? Anybody? What do you mean by valence cell? Yes, please.
Outermost shell.
Outermost cell we used to call it as valence cell. So whatever it is, it may be a K shell or maybe a M shell or maybe a L shell or whatever it is. So that is called as outermost shell is called as valence cell. That is what it is. Everybody knows or not? Valence cell means outermost cell. Next, we studied valence electrons. What do you mean by valence electrons? Valence electrons. Yes, please. Others also should respond. What do you mean by valence electrons?
So
Yes,
electrons in the valence.
yes. The number of electrons, total number of electrons present in which cell, guys? Total number
Valence.
of electrons present in which cell, everybody? Electrons present in valence cell is called as valence electrons. Same way. Next, last thing we studied, what do you mean by valency? Everybody, at least this definition, don't know. What do you mean by valency? Yes, please. Combining capacity of an element means combining capacity. What do you mean by combining capacity, Mr. Omar? Yes, please. Maximum, how many it can donate or it can receive, donate or receive, or we know another thing. What is that? How many it can?
Share.
Share the electrons. So that is what we used to call as valency. Now, if you know these three definitions, it is very easy to calculate the valency. That is what calculation of valency for metals and same way for non-metals. Now, let us write calculation of the valency first from number 1 for metals. Write it all of you. For metals. So now observe very carefully. At last, I will form the one single statement and make you to understand all the valencies also. Now for metals, you remember metals have their valency, right? Metals have their valency equal to the number of valence electrons. Have you understand, everybody? Equal to the number of valence electrons. That is a simple statement. If you want to remember, for metals, valency is equals to number of valence electrons. Are you clear, everybody? Yes, please. Number of valence electrons is itself is called as valency. So that is what for metals alone. Now, let us write valencies of some metals so that you will understand. So tell me, what is the known elements for us, known metals? First, so many times we have written. Let us start with the element name. So we all knows that element, it is having down subscript what we can say and superscript what we is to represent. If you take element, symbol is X. What is subscript represent? I taught you all people. Yes, please.
Atomic mass.
atomic number Z and superscript what it will represent?
Mass numbers.
Mass number A. Don't act like don't know anything, you have to respond. Now, as we know, atomic number means only number of what? Number of
Protons. Proton.
and mass number means number of protons plus another thing. What is that? Number of protons plus
Neutrons.
number of neutrons. That is what. Now, if you have taken element, let us take now lithium. So we all know lithium. So lithium atomic number is 3. Okay, that is what it is. Now let us write the electronic configuration. Can you tell me the what is the electronic configuration of lithium fastly?
2,1, sir.
Who is this user? Modify your name. Otherwise, leave from the meeting. There is no objections at all. Please make it Mr. Saravan. This is also modify your names. Otherwise, I don't know who is that. So lithium, what is electronic configuration? Everybody, tell me fast.
2,1.
2,1. So its valency is also. So what is the valency? Metals. Check it, everybody. Everybody say what is valency? Number of
Number of valence electrons.
electrons. So what is the valence electrons here? Arun Kailash? 1.
1, sir.
Its valency is also 1 only. So I can say 1. Of course, metals, they will donate the electrons or they will receive the electrons. Donate, so that they will form plus cations, positive ions they will form. That's what 1 plus will write. Same way, you take sodium. So what is atomic number of sodium? Everybody?
11, sir.
Sir, no. So what is atomic, what is electronic configuration? Fastly, everybody. 2,
2,8, sir.
1. So again you can see here, again same thing. So here also 1. So that now what is the valence of sodium? Everybody.
1,
sir.
So that is what, or we can say 1 plus, because by loss of electrons, they will turn into positive. Is it yes, everybody? Clear?
Yes, sir.
Mr. Hari Krishna?
sir.
Next, let me take magnesium. We all know magnesium. Can you tell me what is the atomic number of magnesium? Fastly.
12, sir.
Clear?
12, sir.
If you have taken electronic configuration, speak everybody. 2, 8, 2. So now, what is the valence electrons?
2 plus, sir.
2.
2, sir.
Its valency is also either 2 or we can say 2 plus. Understand, Mr. Sanjay? That is. Next, magnesium after. Let me take aluminium. So we all know aluminium. So aluminium is 13, 1, 3. So now 2, 8, 3. So this is what it is. So now tell me, what is the valence electrons?
3 plus. 3, sir.
So its valency is what? What is its valence? 3 or we can say 3 plus. Now we all know potassium. Can you tell me what is the symbol of potassium? I want response from everybody. Danishkar, potassium symbol.
Yes.
Yes, sir.
Please. K. What is the atomic number of potassium? 19. Now can you tell me what is the electronic configuration fastly, everybody? 2, 8, 8, how much are it? 2, 8, 8,
1.
that is what totally 19. What is the valency? 1.
1, sir.
Now we all know calcium. I taught you. Calcium, what is the atomic number? 20. So now, what is the electronic configuration? 2, 8, 8, 2. So that is what? So what is the valency?
2, sir.
Yes, please. How much?
2, sir.
Or we can say 2 plus. So that is what you have to remember. So that is what about the metals. So metals valency means its valence electrons. Very simple. If it is a metal, whatever it is present in valence cell is called its valence electrons. That's all. Write it. Are you clear, everybody? Yes, please.
Sir.
That is what. So take this many examples, nothing, write neatly so that you will understand it. At last, I'll make it very simple. Don't worry. Now you write it. Somebody call to Mr. Akileshwar, Akilan and Gokul, Mr. Johan, Nimish. Just dial them. Tell them, good morning, Mr. Aswin. Can you hear me? Mr. Rohit, join back again. Leave the meeting and join. You are not yet joined properly in meeting. Mr. Nimish, you also. Have you understand? So for metals, what is the valency, guys? Valency means number of
Valence electron.
That's what you have to remember it. Now, completed everybody? Yes.
Yes, sir.
Next,
Yes, sir.
Roman number 2. So metals we made it. Then for what next? For what? For
Non-metal.
non-metals. So let us go with for non-metals so that you will understand. So let us write everybody. So remember non-metals. Not all the non-metals, of course, some non-metals like carbon, they'll be having 4 also. That is also we'll discuss it. So for basically we'll write non-metals, right? Non-metals have non-metals have 5, 6 or 7 electrons. 7 electrons in their valence cell. In their last cell. Last cell means what is another name of last cell? Everybody.
Valency.
Valence cell, not valency cell. Valence cell. Keep it in mind. Last cell and their valency can be and their valency can be. Can you tell me when an atom will be stable? I told you so many times. Anybody? When an atom will be stable in nature?
Sir, 8.
Sir, valence electron, 8 electrons.
When it has 8 electrons in its valence cell, it will become stable in nature. Yes or no, everybody?
Yes, sir.
That is what. So, and their valency can be calculated. Valency is equals to 8 minus number of valence electrons. 8 minus number of valence electrons. That's all. That is the formula. So for metals, what? Valence equals to number of valence electrons. But non-metals, what, guys? Valence equals to, yes, please.
8 meters.
8 minus number of valence electrons. So 8 only we can call it some rule. Can you tell me what is that rule called as?
Octet rule.
Octet rule. And only one cell is there. That cell is K cell. And maximum how many electrons? Only
2
two.
electrons.
What is that rule called as?
Duplet.
rule, sir.
Duplet rule. Mind that. Okay, everybody, Mr. Noor, Omar, that is what. Now, let us write non-metals, element. So let me take the most popular elements for us. That is what nitrogen. Can you tell me what is the atomic number of nitrogen? Let me see who will say.
7, sir.
7. Okay. Atomic number of nitrogen is 7. You all should know at least 20. Again, I'm saying electronic configuration. Mr. Nimish will say, others you wait. Mr. Nimish, tell me what is the electronic configuration of nitrogen? Mr. Nimish, can you speak? Can you able to speak? He is sleeping. That's fine. Next. Mr. Rohit, can you tell me? 2,
Sir, 2,5.
2, 5. Very good. Now, Tejaswini, what is the valency? Apply the formula and tell me. What is the valency? Yes, Tejaswini? Can you hear me?
3, sir.
3. How? You should tell me 8 minus 5. That is what I am saying. So, we have to subtract valence electrons from 8. That is what it is. So, 8 minus 5, which is equal to how much, guys? 3.
3, sir.
Is what? Next. Oxygen. Oxygen. Mr. Aswin Balaji, can you tell me what is the electronic configuration of oxygen? Fastly. Mr. Aswardhan. 2, Aswardhan sleeping. Aswin sleeping. Next. 2, what, guys?
6, sir.
2, 6. Make it fast. 2, 6. Arun, you will get a chance. First wait. 2, 6. So here what will happen? 8 minus 6, which is equals to what, guys? 2.
2,
Same
sir.
way. Fluorine. So can you tell me what is the fluorine atomic number, Mitaksri? 9. So 2, 7. 2, 7, which is 8 minus 7, which is equals to 1. Write it. Mr. Nimish, if mic is not working, make it work. Make it work, it will happen. Inform mother. Don't ask me excuses. Next. Phosphorus. Can you tell me what is the atomic number of phosphorus? Mr. Aswin Balaji, I am asking you only. Mr. Saronan also. What's his name? Aswardhan. Phosphorus atomic number is 15. Tell me atomic electronic configuration, everybody. 2, 8,
5, sir.
So next 8 minus 5, which is equals to 3. Write it. Next sulfur. Sulfur, what is the atomic number, everybody? 16.
16.
So 2, 8, 6. So what is our atomic valency? 8
2,
minus
sir.
2.
2.
Next, chlorine. What is the chlorine, Omar? Chlorine atomic number, Omar. Omar also slept. 2, 8, 7. So 8 minus 7, which is equals to 1. So that is what it is, non-metals. Do you understand, everybody? How to write for metals and non-metals? This is what is valence of a metals and what is valence of a non-metals. Clear, everybody?
Yes, sir.
Yeah, write it. Joining in meeting, no use. You must be very active. That's what I want. Good morning, Mr. Akilan. Late always. Write it fast, Mr. Sanjay. Completed. Now,
Completed, sir.
yeah. Now you can see, for example, if you take some elements like carbon. So we all know carbon. What is the atomic number of carbon? All of you. Carbon atomic
6.
number 6. And what is the electronic configuration of carbon? Fastly.
2, 4.
2,
4. So like these elements also, valency is 4, not plus or not minus. So it is valence electrons are 4. This is also we will apply 8 minus 4 only, the 4. But here you can notice it, these electrons, they will never receive or they will never accept, donate or receive. What they will do? This particularly, they will be under sharing of electrons. Remember, when if any element having 4 electrons in its valence shell, then it will undergo neither donation nor accepting or receiving. It will undergo what? It will undergo, yes please. It will undergo sharing of electrons.
Donation.
Now, we all know carbon. So if you have taken carbon, so its valency is represented like this. Class 10th entirely you'll get it in 3 chapters like this. Now this is what carbon. So what do you mean by this carbon means? This 4 dot indicating what, guys? Anybody can tell me? What is indicating here? This 4 dots. They're indicating what? Valency of the carbon, and this structure is only we used to say electron dot structure. What is the structure? Yes, please. Electron dot structure. We will say Lewis dot electron dot structure, or we can say electron dot symbols. Okay, electron dot symbol, or we can say Lewis dot symbols. Please remember. Okay, so class 10th entirely we are going to write like this only. Okay, everybody. So this is what about metals and non-metals valency. Now everything together, shall we form everything together so that it is easy for you to understand? Yes, everybody. Now valence electrons, you might be by seeing here, you might understand valence electrons may present 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 also present. But if 8 is present, what is the valency? 8 is present. What is the valency? Tanishkar? If 8 is present, what is the valency? Everybody? 0. Why it is 0? Because it is satisfying which role? Octet rule. Keep it in mind that. So I'll write now. You can see here everything together. I'll write for entire metals and non-metals. Valence electrons. All of you observe very carefully. Valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Is it okay, everybody? Are you clear? Now I'll write valency. Check it, everybody. Valency. If 1 is there, what is the valency? 1. 2 is there. What is the valency? 2. 3 is there. What is the valency? 3. 4 is there. What is the valency? 4. Are you clear? Now 5 is there. What is the valency? Everybody respond, guys. 8 minus 5, 3. 6 is there. 8 minus 6. How much? 2. 7 is there. 8 minus 7. 1. 8 is there. 8 minus 8.
0.
Okay. This is what you have to remember. Now, 1, 2, 3. What they are called as? Metals or non-metals? Metals.
Metal.
This one. Maybe metals, sorry, non-metals, or maybe metalloid. Understanding? Metals, non-metal, or metalloids. Okay, metalloids means silicon, you can take example, and metals mean non-metals means carbon, you can take example. Next, this one, who is that? Non-metals. And last one, who is that? Noble gases. Okay, or we can say inert gases. Clear? Write it. Here one more inert gas will come, including whom? Yes, please. Including whom, guys? Helium. Okay. Helium even having only 2 because it's having only K shell, but still it is inert gas. Now, single statement, will you able to remember enter valency or not? I want answer from you. Are you clear?
Yes, sir.
So please make it that. Write it. Any doubt anybody can ask me. Hope everybody understood. Sanjay, Akilan,
Sir.
yeah, please make it. Mitaksri, anything doubt, Mitaksri?
No doubt, sir.
It's completed. Please let me know. Umar, Mr. Noor, over. Okay.
Completed.
Yeah. Next, right. Good morning, Abhirami. Late. Next, right. Formation of ions and calculation of their valencies. So what kind of ions you have? I want answer from you. What is the ions we have? Two ions we have. By loss of electrons, one kind of ions. By gain of electrons, one kind of ions. Anybody?
Cation, anion.
By loss of electrons, what they will form? Tejaswini?
Cation.
Yes, please. Cations will form. By gain of electrons, what they will form?
Anion.
Anions. Okay. So for ions, how to calculate the valency? Let us write it. Okay. So all of you put formation of ions and calculation of their valencies. When ions will form, anybody can tell, a boy or girl, anyone. When ions will form? By loss of electrons or by
Gain of electrons.
gain of electrons? Formation of ions and calculation of their valencies. Formation of ions and calculation of their valencies. Okay. So we all knows that ions. Ions are two types. What is the two types of ions, everybody? One is cations and another one is called as anions. Okay. Now, this form, ions will form only by what, guys? By sharing or by loss or gain of electrons? Yes, please. Loss or gain. So ions are formed by the loss or gain of electrons. Please make it. Okay. So let us make first kind of ions. What is the first kind of ions, everybody?
Cation.
Cations. Very, very important in class 10. Remember, cations and their valency. Cations and their valency. So shall we start now? So who will form the cations? Metals or non-metals? Yes, please. Mr. Nimish, Danishkar, Gokul, who will form the cations? That is what my question.
Metals, sir.
Metals. Very good. So remember, the metals are electropositive in nature, right? The metals are electropositive in nature and have what is the valence electrons? Valence electrons. Metals valence electrons. 1, 2 or 3 electrons in their which shell, guys? Nobody will say.
Valence shell, sir.
Valence cell or outermost cell, right? Valence cell or outermost cell. Due to electropositive nature. Electropositive means loss of electrons or gain of electrons?
Loss of electrons.
Loss of electrons. Nature. They lost the electrons and acquire which charge, Mr. Harish?
Positive charge.
Positive charge.
Those who are active always they will study well. Those who are acting, they will never. I'm keep on calling. Mr. Omar slept. I know. Charge to form cation. Please make it, everybody. So this is what about it. Mr. Gokul, are you clear? Who will form the cations? Metals or non-metals?
Metals.
Metals.
Yes, sir.
Right. Positive charge. This positive charge is equals to this positive charge. This positive charge is equal to electrovalency, or we will say positive electrovalency, your choice. Okay. So now, shall we write the examples? Now, what is the changes will takes place? You observe very carefully. When an atom turns into ion, as we know that either it will lose the electrons or it will, everybody, it will
Gain
Gain.
electron.
gain the electrons. Now, if it will lose the electrons, we are calling as a cation. So, what is the changes will happen? You observe very carefully. Now, the first example which I am taking again, sodium. So, we all know sodium. So, what is the symbol of sodium? Fastly,
Na.
Na. What is the atomic number of sodium? Fastly, everybody.
11.
11. What is the electronic configuration of sodium? Fastly, everybody. K
2,8.
2,8, 1, sir.
8, 1. So now tell me how many electrons it can lose to become stable in nature? Everybody,
1
one
electron.
electron. Just now we studied. If one is the valence electron, then what is the valency also? One is the valence electron. What is the valency?
1, sir.
1. That is what you have to remember. So it will lose how many electrons? One
One
electron.
electron.
So as I told, loss of electrons, which side will come? Product side or reactant side? Reactants gives product. Now tell me which side electrons will come? Loss of electron. Product side or reactant side? So many times I told you. If I write in reactant side, it is addition of electron. If I write in product side, it is
Product side.
loss of electron. So where it should write? Loss of electrons. Everybody.
Product side, sir.
Product side. Keep it in mind that. So now I will take sodium. Sodium atom. This is atom. So what is electronic configuration? Everybody. Yes, please.
2,8,
2,8,
8, 1. Now this sodium loss by loss of electron. Loss of electron. Be very careful. Understanding? It will turns into sodium ion. This is ion. So how many electrons it will lose, guys? Fastly. 1 electron.
1
1
Okay.
electron.
Now 1 electron gone. Then can you tell me what is the electronic configuration of this one? This is KLM. Now here what? Electronic configuration. 1 electron gone.
K.
Then how many remaining? 2, 8.
8, sir.
K and L. So now observe very carefully, all of you, and tell me what is the valence cell in sodium atom? What is the valence cell in sodium atom?
M shell.
M, sir.
Shell. What is the valence cell in sodium ion?
L shell.
L
L
shell.
cell. Now, L cell, how many electrons are there? Check it.
8.
8.
8
So that
electrons.
is why sodium atom is stable or sodium ion is stable. Everybody.
Sodium ion is stable.
Sodium ion is stable. So that is the reason it will lose the electron. Why it will lose the electron? To become stable in nature. Understand, Mr. Rohit? Tejaswini? That is what you have to remember. Clear? So that is what. So sodium metal is electropositive and its valence is how much? Tell me. Sodium metal is electropositive. Please write it and join in the meeting without fail. Sodium metal is electropositive and its electrovalency. How much, guys? Electrovalency. You tell me.
8, sir.
1 plus. Electrovalency means valency. How many electrons it will lose? 1. So 1 plus is the electrovalency. Now, shall we draw the structure? Everybody, are you ready? Structure? Yes, please.
Sir.
Yeah. So if you have taken sodium, atomic number is 11, mass number is 23. Now, can you tell me what is the number of protons? Fastly, I want to know everybody. Number of protons. Number of protons, 11.
10.
Number of electrons, 11. But number of neutrons, how many? Number of neutrons, how many guys? 12. How it will be, I will say you. Meeting is going to end. Join back. I will say you that. I think you people forgot it again. Make it.
Sir,
Sodium
11.
metal is electropositive and its electrovalency is 1 plus. Till here completed. Anything doubt? Ask me. You need to know atomic number and mass